welcome to Remarkable Relations and Fanciful Functions. Let's get started with some definitions. A relation is a set of ordered pairs. The domain of the relation is the x-coordinates of the ordered pairs. And the range, you guessed it, is the y-coordinates of the ordered pairs. Now the domain can also be referred to as the abscissa, the input, and the independent variable. So there are 4 different terms you need to know in relation to domain. There are also 4 terms relating to the range, and they are y-value, ordinate, output, and dependent variable. Now there's a nice little coincidence here that can be used to help you remember which is which, and most of the terms go in alphabetical order. In other words, D comes before R, X comes before Y, A comes before O, and I comes before O, and that's where it ends. So given the relation 3, 2, 1, 6, negative 2, 0, find the domain and find the range. So we would just list those as the set of values. Notice that as we discussed when we learned about sets, these do not have to be in numerical order. We can just list them because they're just a listing of those values. Now relations can also be shown by tables, what we call mappings, or also graphs. And finally, just the set of ordered pairs. Okay, so here's an example for you. Given the following table, show the relation, the domain, the range, and the mapping. Why don't you pause here and go ahead and give that a shot. The relation is just, as we said, the set of ordered pairs listed. Make sure yours have parentheses because they are ordered pairs. The domain is just those x values. The range is the y values. And the mapping, you have to draw 2 ovals and associate each x value with a y value by drawing a line. Now notice that we don't have to write any values that are repeated twice. We can just use a line mapping to each of those values. What is the domain of the given relation? You guessed it, it's number 3. The range of that relation? It is 4. 1, 2, and 3. 1 is a repeated value. Okay, now some more terminology. Relations can be discrete, which is basically a set of points that are on a graph, and those are examples that you can see. These are only certain numbers in a given interval. Continuous relations are those relations that contain all of the values in a given interval. Discrete examples would be something like integers in the range 1 to 5. So integers are only going to take on those positive and negative whole numbers. They are represented by dots and they are countable. So examples would be like the number of glasses in a cupboard, the number of M&Ms in a bag, or the number of students in a classroom. Continuous examples contain all of the numbers in that given interval. So there's no space between the data values. They're represented by solid lines, and they can be measured to a precision beyond what is shown. So it doesn't look like we could measure in between the 2 and 3 to the 10,000th place, but if we zoomed in on that, we could. Examples would be the number of ounces in a glass, the weight of a chocolate chip, or times in a race. Discrete and continuous are actually quite important concepts as we get into our discussion of functions. Another concept we are going to discuss is the inverse of a relation. The inverse of a relation is the relation formed when the independent variable is exchanged with the dependent variable in a given relation. So basically, what does that mean? Think about that definition. The independent variable is exchanged with the dependent variable. Well, the independent variable is which? That is my x value. So the x value is exchanged with the y value in a given relation. So basically all we're going to do is we're going to take the relation, which you should write, and that should be the set of ordered pairs, and we are going to exchange the dependent with the independent variable. So I'm going to exchange my x with my y, and that would be the inverse of that relation. So write the inverse of this mapping. It's going to be number 1. Now we're going to get into the concept of a function, and a function is a very specific mathematical term. It is a relation in which each element of the domain is paired with exactly one element of the range. So another way of saying it is there is only one output for each input. That means x cannot be repeated with different y's. I don't care about y can do whatever it wants, but x cannot be paired with different y's. So my input going in to the function is paired with exactly one out. This is what we call function notation, and we'll be doing more with this in the coming days. And basically it's saying that my output is whatever I got when I put in a certain value. So the name of the function in this case is f, and it is read y equals f of x. That is not parentheses x, it's f of x. Now we're going to determine whether each relation shown is a function. Is this a function? Well, the first thing I do is I look to make sure x is not repeated. X is not repeated. So since x is not repeated, I don't have to worry about it. It's a function. 2 maps to 3, 3 maps to 0, 5 maps to 2, and 4 maps to 3. Every domain is different. The second example, 4 is paired with 1, 5 is paired with 2, 5 is paired with 3, 6 is paired with 6, and 1 is paired with 9. So not only do I have the domain repeated, but it's repeated with different y values. That is not allowed. That means that relation is not a function. If I take a look at 1, 3, 2, 3, and 3, 3. 1 is paired with 3, 2 is paired with 3, 3 is paired with 3, and your initial intuition tells you that something's wrong with that. But in fact, the way we define a function, that's fine. Y can do whatever Y wants to do. It's X that is restricted, okay? So this, in fact, is a function. Now, a way to tell that a graph is a function is what we call the vertical line test, also known as a pencil test. And that says if any vertical line passes through more than one point on the graph, then the relation is not a function. So basically, we take a look at the graphs and we draw vertical lines trying to make it hit our graph in more than one spot. If we are unsuccessful, then it in fact is a function. So this red line, any way I draw vertical lines, I'm never going to hit that red line more than once. So that is a function. This is a discrete relation, and no matter how I draw my vertical lines, I'm never going to hit more than one point. So that is also a function. The ellipse has many points in which almost all the lines, with the exception of the ones on the ends, hit my graph in more than one spot. So that means it is not a function. It only has to fail once. Let's take a look at the next several. A horizontal line, yes, that's also a function. It's going to be fine. A vertical line, however, I can't just try to pass the vertical line test. I have to try to fail it. So this particular line that overlaps my vertical line would make it fail the vertical line test. This is a sideways parabola, and if I draw these vertical lines, it's going to fail in many spots. So that is not a function. This is called a step function, and we will be doing this later on when we do other functions. Now what this is saying here is that if I have this spot, it's fine here, but this is not a point on my graph. So if I draw my vertical lines, that is going to pass the vertical line test. Now you are asked to also give the domain and the range for each of your functions. So let's talk about that for a quick minute. You should be using set notation to describe what values the relation can take on. So for instance, if I'm looking at this horizontal line, I think it's number 4 for you. That is a line even though my graph doesn't show arrows. If I think about my domain for that, that's what x values would be included in that graph. Well, basically all reals, okay? So I could go from negative infinity to infinity. Now if I think about the range, the only value this function takes on is where y is 2. So that's the only thing in your range. That's going to be just the set with the value 2 in it. So do your best with those, and we will regroup and check it out tomorrow. Now you do have some practice on page 4, and what I would like you to do is graph those particular relations, determine if it's a function, give the domain, give the range, and check out the vertical vertical line test, and then sketch a relation that meets the criteria that you are given. Those are some excellent questions, and we will touch base tomorrow and make sure everybody's A-OK. Have a wonderful evening.